And somebody earlier asked about LED lights and flashers and whatnot, so I wanted to cover that real quick, and then I'll quit trying to put you all to sleep. LEDs have been an amazing advancement in light technology. If you take a look at like your turn signal bulbs in most of these old cars, they were, I don't know, what are they, somewhere between 7 watts and 15 watts each. So let's, just for round numbers, again, don't hold me to numbers here, but let's say you've got a 15 watt bulb left and front and rear on the left side. So you got 30 watts there that your flasher has to operate. Well, that flasher, the way it works, like I said, it's basically a piece of metal with a coil of wire around it, and that coil heats up, warps the metal, and when the metal warps, it breaks contact, so it shuts the flashers off. Then they're back on. As it's on, it's heating up, then it breaks. On, off, on. That's how the flash works. Problem comes when you put LED bulbs in. Okay, the old bulbs, like I say, let's say each one was 15, so you had 30 watts of draw on that side. At 12 volts, what is that? Slightly under 3 amps, right? Well, the new LED bulbs, they might only draw 1 watt for twice the light output. And the problem is, you put your turn signal on, this will never heat up. It'll never break contact. So you have to go with an electronic flasher to make the LEDs work. But they make them, and you can do it. Where you get into a challenge, like I say, is some of the electronic flashers are not made for positive ground, because being electronic, it is polarity sensitive. The old ones weren't polarity sensitive at all. But when you get into electronics with a circuit, the polarity becomes an issue. So, but there are positive ground electronic flashers out there that you can get. But the LED lights are a good thing overall, and they're actually good for the car because they put less load on all your wiring and all your connectors. So it is a win-win-win in electronics. The LED technology is better. And kind of the same thing with the electronic ignition. The old points drew a lot of amps, and they were arcing and things were wearing and all that. You go electronic, you do away with all that. As far as, you know, some of the things for a street-driven car, you know, again, I think a Petronix is a pretty good system to go. But I would carry a spare set of points with me if I was going on a very long trip.
Well, even without, like I say, if you really are going on a long trip and you may have problems with that, you're just not going to find the parts and pieces. So
Yeah, yeah,
to back yourself up.
yeah.
But I've also found out that, you know, there isn't anything polarity sensitive in a Mini. And there's no reason to have a positive ground over other than maybe your battery cable would fit better because you didn't change it.
Yeah.
Other than that, basically, there's no reason to worry about your ground. If you got a radio or whatever that's negative ground or whatever, just turn the damn battery around and hook it up.
Yeah, give it a try.
Good enough. All right. Well,
Any questions, anybody? We didn't talk too much about generators and alternators. Yes?
I have a question. Going way back, you talked about cleaning switches.
Yes.
You have a recommendation for a spray
Contact cleaner. We use that CRC stuff. Now there is a difference. There's one that's labeled contact cleaner, and then there's one that's labeled electronic parts cleaner. The electronic parts cleaner is kind of like brake cleaner. It's just made for washing the parts up. The contact cleaner is actually supposed to remove from the corrosion from the contact. In the old days, you could get the best, if you can find it, it's toxic and they don't sell it anymore, was TV tuner chlorine. That stuff had tetrachloroethylene in it, I think. Man, you'd spray that.
Tetraethylchloride.
Chlorine, tetraethyl chloride. Chloride. Yeah, tetraethyl chloride. And that is a very distinctive smell and probably gives you cancer. But boy, clean contact's good. Yeah. That was some great stuff. But yeah, there's a difference. There's electronic parts cleaner and then there's electric contact cleaner. And the contact cleaner is what you want. But even with that, you got to be careful because you'll wash the grease out of the switch. You know. Yeah, well,
which is impossible.
Yeah, which is impossible. Yeah. Well, let's mention that too. Dielectric grease on those Lucar connectors that we're talking about, the bullets that slide into the sleeves. It's always good to put a thin film of dielectric grease on that stuff when you plug it together. It helps get them, it helps get them apart later, and it keeps the moisture out. And that's the thing about Lucas stuff too. They were never designed to be waterproof. On Roger's car over there, it's got a great brake light switch. It's down underneath the frame, and it's literally attached to the brake lever linkage, and when you step on the brake, it pulls, and the contacts kind of slide and hit each other. Okay. Well, all the water splashes up in there, so their solution is there's a hole to let the water run out. So once a month, I expect him to crawl into that car and take a toothpick and clean that hole out, and that switch will probably work fine forever.
No, you're just gonna drive it in the dry.
Yeah. Well, but if you actually look at the switch, when those two contacts come together, because it's supported back here, they do slide, and that's self-cleaning.
Yeah.
I mean, it works, but yeah, you got to make sure the drain hole stays open so the water can run out.
Make a bigger drain hole.
Yeah,
Yeah, exactly.
Oh, it's just a routine maintenance, you know, every 6 hours. Yeah.
Like a British car.
It's a British car, yes, yeah. Yes, Tim? Tim, did you have a question? No, okay. So yeah, so yes.
You were talking about the bug eye and the dash light, the LED.
Yeah.
What exactly was that you were talking about? I didn't quite get what you were talking about.
Well, it'd be hard to diagram because it's kind of involved, but the way that switch is wired, it has the toggle on the dash for left and right, okay? It's kind of, it's quite a bit different than the way turn signal switches on like an MG or anything else are wired. And so what happens is when you put the LEDs in it, and an electronic flasher, you finally find one that'll work positive ground. Because the electronic flasher doesn't need much amp draw to trigger it, it'll backfeed through that indicator light, and the flasher will sit there and flash all the time. Yeah, it's crazy. And so then my first iteration was, no problem, I'll put a diode in this line. Anyways, it took me a while, but I finally built a little bridge rectifier with 2 diodes so that when you select right, because that indicator, let's see, how was that? It's been a while since I did it, but anyways.
Indicator flashes, but the way it's wired, you know, there's the right side and the left side. So whenever there's any signal going to it at all, it just never turned off.
It never turned off. Yeah.
So you had to essentially wire it up that like this is the right side, this is the left side, and never the two shall meet.
Yeah, it was a pretty. I was pretty proud of it when I got it built because what I was able to do, not change any of the wiring in the car, just the leads going to the indicator.
It just had one light for indicator.
Yeah.
Yeah. Diode.
So MGAs did that. And
Yeah.
I think. Yeah.
If somebody wants one, I can look back up. I kept notes on what size wattage and everything diodes I made it out of, and could do that because it was frustrating as heck for the guy that had that car. Of course, now I got to tell you, his LED in the dash is so bright. Oh my goodness!
Seems like
I don't think I can drive. A little overkill on that, but at least he knows when his signals are on.
You never forget to turn them off.
I'll tell you. I promised I wouldn't do horror stories, but I got to tell you a story about this. This is insane. So, my wife's car, those Jaguars, the turn signal sound isn't the flasher you're hearing. There's actually a Harman Kardon speaker in the steering column with a computer-generated click-click sound. Okay. Now wait, it gets better. Okay. The sound, the volume of that is controlled. There are 3 other speakers in the car, and they sense ambient noise in the car, and they adjust the volume up and down depending on ambient noise. Okay, for that and the sound system and a lot of other things. Okay, navigation, all that. It's horribly. I can only imagine, you know, some Lucas engineers. Or of course, this was in the Ford era, but still, you know, designing the system. I mean, it's got 16 speakers in it. It's got all this stuff, right? I'm on the freeway and I see a car like hers, and they're kind of rare. I don't see many of them. And it's, well, an elderly lady driving along with her signal on flashing. I'm thinking after all the work they went through to make that system, and here she is blissfully ignorant of the whole thing. And I'm like, you know, somewhere there's a Lucas engineer weeping in his beer somewhere.
I used a scooter one on an old Ford because I kept it was so quiet. I kept leaving
directionals on for miles. Yeah.
You're that guy.
I put one a scooter one in, and they click really loud.
Yeah. Yeah.
Actually buy loud flashers. They actually sell them as loud flashers.
One thing I was going to mention, because a lot of people have a lot of trouble with this, or usually they have a lot of questions about the charging, the ignition warning light. Okay. Basically, that's kind of a unique system. The way that thing works, it's wired into your ignition, and it's actually wired to the back of the generator or the alternator. And the way that works, it's kind of complicated, so I'll try to make it really simple. Basically, once the charging voltage exceeds the supply voltage on the other side and they become the same or greater, the light goes out. If you think of a light, you need a power source on one side, incandescent bulb. You need power on one side and you need a ground on the other. Well, if your charging side is the field winding and it's not spinning, then that's a ground, so the light's on. Once that starts spinning and producing electricity, and once that electricity or flow of electrons equals the input side voltage, or near about, or maybe just a little more, then the light goes out. But that confuses the heck out of some people. They're like, how does this thing even work, you know? And again, Lucas gets blamed for a lot of stuff, but it's actually a pretty sound engineering system. That's
All right,
it.
any other questions? Have we learned enough about Lucas for one day?
How many people fell asleep?